Welcome to Space Train. In our previous video we discussed what is motion, and how does Newton's laws of motion work. You can find link down below. Today, let's talk about fundamental types of motion. If you are ready, let's begin our expedition. Number 1. Translational motion. Motion that results in a change of location is said to be translational. This category may seem ridiculous at first as motion implies a change in location, but an object can be moving and yet not go anywhere. I get up in the morning and go to work, an obvious change in location, but by evening I'm back at home, back in the very same bed where I started the day. Is this translational motion? Well, it depends. If the problem at hand is to determine how far I travel in a day, then there are two possible answers. Either I've gone to work and back, 22 kilometers each way for a total of 44 kilometers, or I've gone nowhere, 22 kilometers each way for a total of 0 kilometers. The first answer invokes translational motion while the second invokes oscillatory motion. Number 2. Oscillatory motion. Motion that is repetitive and fluctuates between two locations is said to be oscillatory. In the previous example of going from home to work I am moving, but in the end I haven't gone anywhere. This second type of motion is seen in pendulums, like those found in grandfather clocks, vibrating strings, a guitar string moves but goes nowhere, and drawers, open, close, all that motion and nothing to show for it. Oscillatory motion is interesting in that it often takes a fixed amount of time for an oscillation to occur. This kind of motion is said to be periodic, and the time for one complete oscillation, or one cycle, is called a period. Periodic motion is important in the study of sound, light, and other waves. Large chunks of physics are devoted to this kind of repetitive motion. Doing the same thing over and over and going nowhere is pretty important. Which brings us to our next type of motion. Number 3. Rotational motion. Motion that occurs when an object spins is said to be rotational. The Earth is in a constant state of motion, but where does that motion take it? Every 24 hours it makes one complete rotation about its axis. Actually, it's a bit less than that, but let's not get bogged down in details. The Sun does the same thing, but in about 24 days. So do all the planets, asteroids, and comets, each with its own period. Note that rotational motion too is often periodic. On a more mundane level, boxy balls, phonograph records, and wheels also rotate. That should be enough examples to keep us busy for a while. Number 4. Random motion. When an object moves in an irregular, random, haphazard or disorderly way, the object is said to be exhibiting random motion. An example of such movement can be observed in butterfly movement or Brownian motion that occur in gases. Random motion occurs for one of two reasons. Chaos theory. Some motion is predictable in theory but unpredictable in practice, which makes it appear random. For example, a single molecule in a gas will move freely until it strikes another molecule or one of the walls containing it. The direction the molecule travels after a collision like this is completely predictable according to current theories of classical mechanics. Every measurement has uncertainty associated with it. Every calculation made using the results of a measurement will carry that uncertainty along. Now imagine that you are trying to predict the motion of 1 billion gas atoms in a container. That's a small amount, by the way. After measuring the position and velocity of each one as accurately as possible, you enter the data into a monstrous computer and let it do the calculations for you. Since the measurements associated with each molecule are a little off, the first round of computation will be a little wrong. Those wrong numbers will then be used in the next round of calculation and the results will be a little more wrong. After 1 billion calculations, the compounded error would render the results useless. The molecule could be anywhere within the container. This type of randomness is called chaos. Quantum theory. Some motion is unpredictable in theory and is truly random. For example, the motion of the electron in an atom is fundamentally unpredictable because of a weird conspiracy of nature described by quantum mechanics. The harder you try to locate the electron, the less you know about its velocity. The harder you try to measure its velocity, the less you know about its location. This is fundamental quality of small objects like electrons, and there is no way around it. Although the electron is often said to orbit the nucleus of an atom, strictly speaking, this isn't true. The probability of finding the electron at any particular point in space is predictable, but how it got from the first place you observed it to the second is actually a meaningless question. There is no name for this kind of motion because the concept of motion doesn't even apply. Number 5. Relative motion. Relative motion occurs when one object is at rest but perceives motion when looking at an object that is moving. For example, when traveling in a moving bus, if you look out the window at unmoving objects, that is houses, parked cars, fence posts, those objects appear to be moving backward or behind you. In this example, the bus is moving relative to the objects outside. Though the objects outside the bus are unmoving, they appear to be moving. When we talk about the velocity of something, we first determine a reference point, and then according to this reference point we say the velocity of the object. For example, you are in a bus and it goes with a velocity of 50 meters per second to the east, then a truck passes you with a velocity of 60 meters per second to the east. When the truck is next to the bus you feel that as you go backward to the west, or when the two cars have same velocity when you look in another car you feel you do not move. On the contrary, consider the below examples. If you look at the stationary objects at the ground when you travel, then you feel yourself travel with the velocity of the car. All these are the result of relative motion. Velocity of the moving objects with respect to other moving or stationary object is called relative velocity, and this motion is called relative motion. Reference point is too important in physics. We do all calculations according to the reference points. For instance, we observe the plane flying in the air. Velocity of that plane with respect to us is the sum of the velocities of plane and the wind. However, the same plane has different velocity with respect to the flying other plane. That's all today. Don't forget to comment what topics would you like to discuss in our next video. There are lots of questions left, so don't space out. Our next expedition will If you are still here, grab your knowledge and get out of my train.